Bienvenidos, Ushamdid, and welcome Anne Arundel Community College learners from the CTS-130 Section 402 course for the spring 2021 semester. This is the Cisco Networking Academy's Introduction to Network version 7 course curriculum, and in this packet tracer tutorial and activity, we're going to be taking a look at Troubleshooting Challenge 17.8.3. Again, this is the culmination of all of the knowledge that you have gathered to this point in the course. And so let's dive in and take a look at what we're going to be required to do. Now you can see over here on the left-hand side, this topology should look very familiar to you from activity 17.8.2, with the exception that all of the addressing information seems to be filled in here over on the right-hand side, and we're no longer using that 192.168.0/24. It looks like we're using the 172.16.1.0/24, and it looks like that's been subnetted here, and we'll find out a little bit more as we work with this activity. So, objectives, we're going to troubleshoot common LAN issues. Again, this is the culmination of all of the knowledge you have gathered, and now you have to apply that knowledge in a troubleshooting scenario. And so after an update to the network, some network devices were misconfigured. We've got to correct those configurations and verify that all PCs can access the web server, router 1, the switches, and the switches. And the PC should be able to access router 1 using SSH. So if you did activity 17.2 or 17.8.2, you should be on track already to kind of have an idea as to what is going to be required here or what could have been done to this network. And again, we're going to verify connectivity for both IPv4 and IPv6 except for the switches. Remember, with switches, there is a switch database manager, SDM template, that you would have to apply that I don't believe they support here in Packet Tracer. So we've got our passwords, username information, and here we see that they've kind of switched up what the subnets are going to look like. So let's just go ahead, let's dive in here. Let's jump on, again, because the question is, well, where do we begin? Well, let's just start with the top PC here, the ITPC. Now, here is the ITPC. We've got the NIC information and what should be all of the addressing information. And let's go ahead and see, can I ping my default gateway? And the default gateway for the ITPC is listed as 172. Whoops, sorry, I didn't want to type ping in there. Let's type it over here. I want to type in 172.16.1.62. So let's see if I can even get to my default gateway. And there are different troubleshooting methods you could use. I'm going to use sort of this follow the path, and I'm going to do it from the ITPC to the router, and then from marketing PC to the router, and the R&D PC to the router. Because if we can get to the router, we should be able to get out to the main router and the internet service provider, and then the website. So now we look at this, and I see, well, I can't ping anything from the PC. So what do? Well, let's check the PC configuration. Let's see what values we have in here. So the ITPC should be 172.16.1.1 and a /26. And we immediately notice that the reason that we couldn't ping is because I don't have the correct IP assigned here. So let's sort this out. Let's fix our 172.16.1.1. Again, kind of an odd IP for a PC on a subnet, especially if it's the first usable. Usually that goes to the router, but again, they're trying to make it a little challenging here. And we just picked up 9 percentage points for that. Now, it says it's a /26. And if it's a /26, what that means is that the first 2 bits in the last octet here are going to be borrowed for network bits, meaning the last 6 bits, 1, 2, 3, 4, 5, 6, these are my host bits. And so how do we figure out the number of usable IPs? Well, we take 2 raised to the number of host bits, and that gives me the total number of IPs as well as the block size. And 2 to the 5 is 32, so 2 to the 6 is 64. I subtract 2, 1 for the subnet ID and 1 for the broadcast address, and I end up with 62 usable IP addresses. And we're going to let that sit here. Now, just as easily as figuring this out for the host equation, all we do is take 2 and raise that to the number of borrowed bits in this last octet here, and it's 2, so it's going to be a creation of 4 total subnets have been created, and the block size we know is 64, but what are the values here for this dotted decimal subnet mask? Well, 128 and 64 is 192. Again, this is the 128-bit position here, and this is the 64-bit position here. These 2 high-order bit positions in the final octet going from left to right. So let's go ahead and take a look. And yes, all right, fantastic. We've got the correct subnet mask in dotted decimal notation. Now let's take a look at the default gateway address. And so what we can do is we can look here and say, okay, 192.168.1.62, and then come up to router 1 and see what does it think the default gateway should be in terms of the address on the gig 00 interface. And how do we know it's the gig 00 interface? Well, I can mouse over here in Packet Tracer, and again, you can see gig 00 here on router 1. What I could have also done on the router was go in and shut the gig 00 interface down. That would conclusively determine, but I'm not waiting for spanning tree, and I'm not going to do the fast forward arrows, so we're just going to mouse over here. All right, so this value looks good. The DNS value, now, we don't know if this is legit. We'll find out as we work our way through when we try to ping the web server. And actually, you know what? There is no host name. There's no fully qualified domain name for that web server, so we'll have to trust that these DNS values are correct for right now. And again, I don't see those DNS values indicated over here anywhere, so chances are those are already correct. We take a look at the IPv6 address for the ITPC, and here it's 2001 DB8 cafe : 2/64. And does this look good? 2001 DB8 cafe : 2. The link local address FE80 : 2 looks good, and the default gateway of FE80 : 1. And again, we should be very comfortable with these values here from 17.8.2, where we saw these exact same values being used on the PCs in each of the networks. And the DNS server, we're just going to roll with the DNS values right now. So let's pull the command prompt back up and let's rerun that ping command. So now, can I ping the default gateway? And I can. So I'm pretty confident that the PC configuration is correct. So now let me try to ping the switch IP address, right? So I'm kind of doing the follow the path. We're confident the PC is set up and that the PC is good to go. So now I move to the switch. So can I ping 172.16.1.61? So can we ping the switch? Switch number 1, and it's the switch virtual interface. Again, and I apologize, and that ping command is definitely not going to work for us. So let's do 172.16.1.61. Again, I was looking over at the addressing table after I had hit enter there and didn't even realize that I had a IPv4 address there of some kind. So again, so here we go. We've got ping connectivity to the switch, and that indicates to me that the switch is functional. So let's see if I can ping all the way out to the web server at 64.100.0.3. So from the ITPC, can I get out of this network and get over to the web server and take a look at that. So the IT PC looks good to go. Let's go ahead and test some IPv6 now. Can I ping FE80::1, my default gateway on router 1? That works. Let's check the IPv6 address of 2001 DB8:cafe::1. So it looks like the router is properly configured as well. Again, no IPv6 work to be done here on the switches. And so now let's go all the way out to the web server, 2001 DB8:ACAD::3. And I can ping the IPv6 address of the web server. And if that is true, then we should be working here when we say, and they don't give us the URL, and that's okay. We don't need it, right? Now you'll notice it doesn't say IPv4 page here. So this will be, we're going to have to keep our eye up here on the addressing, the URL bar. So 2001 DB8:ACAD::3, and take a look at that. We can hit the, well, let's make sure we can hit these pages here. All right, so there is the IPv6. So we hit the main page, but it looks like, and again, this may be, Packet Tracer was a little slow on the take here with IPv6 earlier, and we'll give it a second. In fact, while that's doing its thing there, let's go ahead and let's come over to the marketing PC. Again, we hit the main IPv6 page and we can ping, so I think we're in good shape. So let's take a look at the IPv6 page. And again, the scenario here is we've got the documentation of what the network was configured as over here on the right in our addressing table. And so this is another reason why documentation is so critical as well. So the marketing PC, let's vet the marketing PC by taking a look at its entries here for IPv4 and IPv6 addressing. So you can see it is also a /26, and it looks like we're doing, well, no, we are doing variable length subnet masking because we have a 25, and then the web is a 29, but totally different network. But we've got this 25 here, and so this 172.16.1 network, or the 172.16 if you'd like to say, has been subnetted down into variable length subnet masks. And so the marketing PC should be 65, and it is. The subnet mask should still be a 192, and it is. Let's take a look at that default gateway address, 126. That is correct, and it looks like the DNS values are going to be the same, so we're good there. What about IPv6? 2001 DB8:cafe::2/64, and that's good. Link local is correct, and the default gateway is correct. So let's go ahead and test. Can I ping? And let's start with our IPv4 information, 192.168.1.126. And let's see if the marketing PC can ping the what should be the gig 01 interface here on router 1. And it looks like we've got an issue here. Now, is the issue the PC? Did we miss something? Or is it the router interface? Well, we can eliminate the PC if we ping the switch 2. And again, assuming switch 2 is properly configured. So let's ping switch 2, 172.16.1.125. And again, it pulled up and did, I'm not sure where it's getting that. So here, I'll just come back all the way. And I'm sorry, I did 192. I just realized I did 192, so it's a good thing I had that mistake there. So ping 172.16.1.126. So can we ping the default gateway using the right address? And I'm in that 192.168 mode here. All right, well, fortunately for us, it looks like, or unfortunately, however you want to look at it, it looks like it's still not going to work. So I can't ping what should be the marketing PC default gateway. So now let's take a step back here. And when we get the output back, now let's see if we can ping switch 2, which should be 125. So can we ping switch 2? Because again, I'm pretty confident that the PC configuration is on point. And so we cannot ping switch 2. So let's go take a look at switch 2 here. And we're going to put the console line password in, which is Cisco ConPA55, and we should be very comfortable with that at this point. We'll go from user exec to privilege exec, where we're going to say Cisco ENPA55, and let's say show IP interface brief. And so you can see there's an IP address assigned here, right? The 172.16.1.125, and it's up, and let's take a look at the running configuration and see how that VLAN is configured. Well, we take a look at the switch virtual interface for VLAN 1, and what do we notice? The IP address is correct, but it should be a /26, and we just did a /26 on the IT network here. And what is, in dotted decimal notation, the subnet mask for a /26? Exactly. It's 255, 255, 255, 192, because a /26 borrows the first 2 high-order leftmost bits out of that final octet. So let's go ahead and let's get into global config, and let's get into interface VLAN 1. And the fix is rather straightforward. We're simply going to change the IP address from the subnet mask. So we're going to say 172.16.1.125, and we're going to change that subnet mask so that it correctly reflects a /26. And we've got 9% right now. We're going to watch that closely, and we bump up 9 points. We are now at 18%, and the SVI has been sorted out on switch 1. And if that's true, then I should be able to ping the 172.16.1.125. And so we get a timeout, and then we are back in action, right? Because those had been subnetted. The marketing PC and switch 2 with the bogus IP were in different subnets, different networks, right? And so that is what we saw on switch number 2. So now let's come back and see, can I ping the default gateway, right? Now, changing the SVI address, right, has nothing to do with the default gateway, and that's why we're running this command, right? To show you that it's not that the IP on the switch has anything to do with routing traffic, right? That is for management traffic on the switch or to the switch. So this is still timing out. Now, if we can go from the marketing PC to switch 2 without any issues, and even if I try to go from switch 2, and let's save our config, remember, I can say ping 172.16.1.126. Can I get to what was configured on the switch here as the IP default gateway? So can the switch get there? Because this will show that the issue isn't with the PC not being able to get there, and the issue is not with the switch not being able to get there, with the PC and switch configurations, that maybe it's something on router 1. And if it is, it's probably on that interface right there. So again, we look over at router 1, and we see that, yeah, that is supposed to be the IPv4 information. Here's the IPv6 information. Let's vet that information. So we get the bonus entry here, ConPA55, and then we go into privilege exec with Cisco ENPA55, and let's just go ahead and say show IP interface brief. And let's take a look at Gigabit Ethernet 01. And as you can see, they had the same. It looks like the network engineer that misconfigured this network was actually me, probably, right? Because take a look, they used a 192.168 here, and that should stick out right away because we've seen that at least one time before, as well as my fortuitous failure with that epic typo that I had. And so you can see that we've got an issue here on Gigabit Ethernet 01. So how do we resolve that? Well, we simply go in, and with IPv4 addresses, we can simply reissue the IP address command and end up with a new IP. With IPv6 and the global unicast addresses, that is not the case, right? You got to be very careful with IPv6 global unicast address entry, global unicast address entry, because things change a little bit. So let's get into interface gigabit Ethernet 01, and let's put in the right IP address command, 172.16.1.126. Now, remember, it is a /26. And we know from experience that that is a 255, 255, 255, 192. So we're at 18%. What are we going to get here? It looks like we're getting about 9% per correction. So we're now at 27%. And if that is true, I should be able to come to the marketing PC, and I can now ping my default gateway. I'm going to come to switch 2. And I can now ping, let's hope here, there we go. I can now ping my default gateway. And so now the IPv4 connectivity has been sorted out. If that's true, I should be able to ping 64.100.0.3 and take a look at that. I can get all the way out to the web server. Now, what about the IPv6 ping? Let's try 2001:db8:ACAD:3. And the IPv6 information from a default gateway perspective, etc., gets me out to the web server. The final test here on the marketing VLAN, or the marketing network, LAN I should say, the marketing LAN, is let's test 64.100.0.3. Can I get to the web page? Look at that. Beautiful. What about the 2001:db8:ACAD:3? Can we get there? It looks like we're at the landing page. And again, it could be a little slow on the uptake. Did the marketing PC ever sort this out? Or I'm sorry, the IT PC ever get to the page? It doesn't look like it did. But we hit the main landing page. I'm happy with that. It doesn't look like, and then it flips back there. So we're okay. It looks like we've got connectivity. So let's go ahead and move on to the R&D network. So again, follow the path. Let's start with the IP. Let's start with the R&D IP addressing information here. And all we have to do is refer to our trusty addressing table. And it's a /25, 172.16.1.129. So the IP address is correct. When I come down and I look at the subnet mask, what is that a subnet mask for in CIDR? Classless interdomain routing notation. Remember, 128 is the value of the first and leftmost high order bit in the final octet, meaning that that would be a value of 128. However, it would also mean that we've only borrowed a single bit and make it a /25. So is that correct? And the answer is yes, it would be. Now, if it was some other slash notation, like a 27, a 28, a 29, that would not be correct. And then what is our default gateway address? 172.16.1.254. So that is correct. The DNS, again, we're just going to kind of let that play out. And then we've got the 2001:db8:cafe:2. And when we look at this, what do we see? Yeah, so 2001:db8::2:2. So we need to come back in here and put a 2:, and let's see if we get some points for that. We do, we get 9 points. And so we were missing that 2 after the cafe. Let's take a look at the marketing PC. Did we have some work to do here maybe with IPv6? No, :1, :2, so things were good there. All right, the link local address is correct. The default gateway address is correct for the R&D PC. And again, we'll let that play out in terms of the DNS value. So let's go ahead and let's follow the path. Let's first try to ping switch 3. So can I ping 172.16.1.253? And that is switch 3's switch virtual interface IP address. And so let's check that out. And we've got connectivity. So everything works great there. All right, so we can ping the IPv4 address of switch number 3. Now let's go ahead and see, can we get beyond switch number 3? Can I ping the default gateway on the router 1 interface? And we can ping that default gateway of 172.16.1.254. And so that looks good from the PC perspective. Let's go ahead and try some IPv6. So I can't do anything with the switch. Remember, that's not going to work. But can I get my default gateway, FE80::1, and that works. Can I ping the global unicast address on that gigabit Ethernet 02 interface? And that's going to be 2001 DB8:cafe 2::1. Whoops, cafe:2::1. Sorry about that. And we can. And so if that works to the router, can I get to the, can I get out to the 64.100.0.3, which is our web server? We can. Let's try that IPv6 information and see if we can get out there. So I'm going to say ping, and we'll do the 2001:DB8:ACAD::3. And that is working, right? So things look good. However, we're only at 36%. And so here's what we've got to figure out. If all configuration problems are fixed, all devices should be able to ping each other in the web server. But let's come back and take a look at this. Did we meet the requirements here? And we absolutely met the requirements here, right? So IT network, can it support 50 hosts? Well, it's a /26. That would support at least 62 usable host IP addresses. Marketing is the same, 50 hosts, and we meet that requirement. R&D, 100 hosts, we're going to be able to support 126. So now the question is, well, if we're at 36%, what is it that we missed? Well, let's go ahead and click onto the router here, and let's take a look. Let's take a look at the router. We'll do Cisco CompA 55. And let's get into privilege exec with Cisco ENPA 55. And let's say show IP interface brief. And so we look at our IP addresses and everything looks good there. Let's say show IPv6 interface brief. And let's see what else we might have that could be incorrect. So all the link locals are correct. Remember, we were pinging those link locals. All of the IPv6 addressing information was correct. So everything looks good there. All right. Well, again, the PC should be able to access R1 using SSH, right? So all of our IP addressing looks really, really good. So if we're at 36% and all the IP connectivity is working, it's got to be something with us being able to configure router 1 for SSH connectivity. So let's go ahead and say show run, and let's just kind of walk through. You can see the login block command is there. Our enable secret is there. The IPv6 unicast routing is there. No IP domain lookup. And there's that very familiar IP domain name. And as we make our way down here, nothing for VLAN 1. You could ignore that on the router. We've got a default route, and here's what a default route looks like with the quad zeros, and then it's basically that's the next hop interface, or next hop IP we're going to go to, which is the IP address of the main router here. And take a look at that. I kind of like this, right? They've got this access list, this extended ACL here. Pretty cool that you can see an example, and it's going to allow, and I don't know if that's actually applied to an interface or not. Did we miss that? Is that on the serial interface? It's not. So they've got this ACL there, but it's not applied to an interface. All right. So here are the VTY lines. No SSH appears to be configured. You've got your VTY lines here. You've got the exec timeout, transport input telnet, right? We know that's going to be an issue. By default, it's transport input all. We want SSH connectivity. So let's get into global config. And what are the steps we had to do? Number 1, configure the domain name, right? Well, that's already been done. If that's been done, we can come in and say crypto key generate RSA, and then we're going to be asked, do we really want to replace the keys? And this I was not anticipating. So let me say no here, because it looks like the keys are already configured. So after the key generation, we need to get into line VTY 0 through 4, right? Now the transport input should be SSH. And let's see. Wow. Okay, that took us to 81%. I was not anticipating that. So now when we say do show run and pipe it to section line VTY, it's transport input SSH. We've got the login local there to use the local user database. When we said show run, did we see a username configured? We did not. So let's go ahead, and we've got the exec timeout, the login local, the transport input SSH. There's no username defined for the local user database. So we've got to get that done as well. So let's come down here and let's go ahead and say username, and we should be familiar with this, admin1. It doesn't ask for privilege level information here, so we're not going to put that in here. And we're going to say secret admin1 PA55. Now, I will be shocked if this is 19 points, although it might be. So let's put the username in here, and it's not. It was 9. So there are 10 points that are still out there to be had here. And so let's go ahead and let's test. Can I SSH? And I don't believe they're going to be giving us points for this. Let's SSH. And remember, that's a -L right there, right? Not a -1. It's -L, admin1, and we're trying to go to router 1. So our address to get to router 1 is 172.16, or I should say our default gateway, which is the address we're going to use, is going to be 172.16.1, and the IT network is 62. So can we get logged on? All right, so what is the password? Well, let's put in for user admin1, admin1 PA55, and there you go. I'm on router 1. Looks good. And we don't get points for that. So let's come back to the marketing PC, and let's see if we can connect via that default gateway address. So let's go ahead and say SSH -L admin1 and 192 again, 172.16.1, and for the marketing PC it's going to be .126. We get the password prompt, so everything looks good. And admin1 PA55, and we're on router 1. That works great. No points for that, however. So we are going to be searching for some points here. And SSH -L admin1 to the 172.16.1, and for the R&D PC, the default gateway value was 254. And let's put in admin1 PA55. And that is all working. So there is something else missing here. Let's reread. Pre-configure with the following. Admin username required host per subnet. So let's check the default gateways on, oh boy. And we're going to have to enter in Cisco Con PA55. Cisco Con PA55. And then let's say Cisco EN PA55. Show run inc default. Okay, so the default gateway is on switch 1. Is it on switch 2? Cisco Con PA55. EN Cisco EN PA55. So show run include default. And the switch has the correct default gateway. Let's check switch number 3 because we're clearly missing something here. Cisco EN PA55. Oops, sorry. Cisco Con PA55, Cisco EN PA55, show run inc default. And the default gateway is correct there. Verify connectivity for both IPv4 and IPv6 except to both switches. So everything, I'm trying to avoid going to the check results tab here. My thinking is it's something here on the router. So let's save our config on the router. And let's take a look at this config one more time. So we've got some service timestamp. Service password encryption is already on. The minimum length is there. The username is properly configured. The domain name is there. No IP domain lookup is there. all of our IPv4 and IPv6 information is there and correct. And so we're sitting at 90. And the serial interface, I don't think we need to touch. I guess let's double check. 2001 DB8. We shouldn't because it's working. Up on router 1 here. And again, this is usually something I overlooked in the activity. 10002, it's a /30, that's right. FE80::1, 2001 DB8:2::1. So that is correct. So even a default IPv6 route out to the main router, which is our next hot banner message of the day. The exec timeout is in there. The password doesn't go on the VTY line because we're using local authentication and transport input SSH. So we're 10 points short here. And I think everything we've done to this point has been correct. And we've tested connectivity end to end. I've got to see if they're going to let me see the check results here. What is it? Oh, the default gateway on IT. I thought we had that right. Let's go recheck that. The ITPC, and everything's working on the ITPC. So what's wrong with our default gateway of 62? That is the default gateway, and the FE80::1. So that, oh, ha! So yeah, 62 is correct. You know what's not? 170. So they, I feel like they did this intentionally, that they had us do all that 192, 168 work, and then they drop us in here. That was the value. But what was interesting is with the incorrect value, that was working. And I wonder if what happened was it was working with the 192 information. You know what it was? So when the IP, this is what I think happened. Initially, if that was a 192 IP, and I'd have to go back and rewatch this, and this was 192, and these values were correct for what would be a /26. And I think, wasn't that the interface possibly? I believe that might have had the wrong, because this worked. IT worked all the way out to the web. So if that was a 192, and this was a 192, and that address there would have been a 192, it would have worked for us. But all those addresses would have been wrong. Again, I could have swore that it worked at one point. So anyway, there we are. That is your troubleshooting challenge for activity 17.8.3. And that really brings to an end our packet tracer activities for the Introduction to Networks course, version 7. All right, guys, if you have any questions, please don't hesitate to ask. And that's it for this activity. Thanks so much for watching, and I hope to see you in the next video.